All right, so the next step in dividing polynomials is to use synthetic division. Yesterday we would have used long division to do the division of polynomials. So today we're going to show you a little shorter version that can be done when you have a degree of 1, and only a degree of 1 by the divisor. We can use this shorthand method. Now, if you don't have degree 1, you have to do the long division. So it can only be done when you have a polynomial of a divisor that is like let's use x plus 1. Okay, so where your degree is 1. So the only time this can work is if your degree is 1. All right, so let's compare the two methods. And so I'm going to go through the long dividing of these two polynomials. So we have x plus 3 dividing into 2x cubed plus 9x squared plus 5x minus 1. Okay? So we take, I would say, how many times is x going to 2x cubed? Well, that would be 2x squared times. We're going to multiply. 2x squared times x is 2x cubed. 2x squared times 3 is 6x squared. Draw your line, change your signs, these cancel. 9x squared minus 6x squared is 3x squared. You're going to bring down the 5x. So how many times is x going to 3x squared? It will be 3x times. 3x times x is 3x squared. 3x times 3 is 9x. We'll draw our line, change our sign. We end up with a negative 4x, and we'll bring down the minus 1. We do it one more time. X goes into negative 4x, negative 4 times, negative 4x, minus 12. Draw the line, change the sign, do cancellation. And it looks like we're going to have a remainder of 11. So that was the long division that we took care of in the previous section. So let's check out how synthetic division works. So synthetic division looks like this. You'll see that it is way faster. So this is kind of like it says shorthand method to get this division done. So we'll bring down this 2. Negative 3 times 2 is negative 6. So we add those together, that gives us 3. Negative 3 times 3 is negative 9, which gives us negative 4. Negative 3 times 4 is 12, which gives us 11. And we reduce the polynomial by a single degree, which is going to give us 2x squared plus 3x minus 4 plus the remainder of x plus 3. And what I had forgotten to do on the left-hand side is just bring the remainder up. And so we had the same answer whether we used long division or synthetic division. So that's the comparison of long division to synthetic division. In the next slide, I'll show you how to set up synthetic division and use it. All right, let's learn how to set up synthetic division and how it works. So the first thing we want to do is just set up a little framework for us to do synthetic division. So we have a little checkbox over here and a horizontal line right here. What we're going to do is we're going to put the 0 from the divisor in that box. This is the divisor. And its 0 equals 5. So how that works is, if we were to take b minus 5 and set it equal to 0 and solve, we would get 5. And so that's the 0 for the divisor. Next to the 0 from the divisor, we're going to put the coefficients from the polynomial. So those coefficients are 1, 1, negative 20, and negative 50. So these are the coefficients right here. Below the black line will be the coefficients. Let's see in there. Let me spell that correctly. Coefficients of the quotient. Will be down here on the bottom, quotient. And the very last number, let's extend this black line, the very last number is the remainder. So that's where numbers go and what they will be when we're done. So let's take the problem that we have and just set it up. And we'll look at, see what happens. So let's, all right. So we'll have a little box and a horizontal line. We're going to use the number 5 because that's the 0. The 0 equals 5. We're going to put the coefficients of the polynomial right next to the 5. It'll be 1, 1, negative 20, and negative 50. So that's how we initially set the problem up. From there, the first number gets brought down. Just bring down the first number. So that's going to be a purple 1. So that 1 becomes the very first coefficient of the quotient. We will then multiply. We will multiply the 0 times the coefficient of the quotient. That product goes right here. So here, 5 times 1 is 5. We will combine these numbers. 1 and 5 makes 6. We will continue to multiply. We'll multiply again, multiply here. 5 times 6 is 30. We'll combine those two numbers. Combine these numbers. Combine these numbers. Negative 20 and 30 are 10. We'll do one more multiplication. This 5 multiplies on this 10. 5 times 10 is 50. Combine these numbers, and we get 0. So the purple numbers at the bottom, 1, the 6, and the 10, become the coefficients of the answer. So we will have 1b squared plus 6b plus 10, and this is telling us we have no remainder. One thing to point out, when we started this problem, it was b to the 3rd power. So we have what's called a depressed polynomial. It's called a depressed polynomial, not bi, poly. Depressed polynomial because the degree dropped by 1. So we started out with a third-degree polynomial, we ended up with a second-degree polynomial, and that's the process of synthetic division. Okay, let's look at some other examples and see if we can't get this process down. So one of the things we looked at with long division is that you have to have all descending exponents. And so there's this rocket over here that says 3, 2, 1, and then it says blast off, right? So we have to make sure that we have all descending exponents. So we have a 5 and we have a 3, but we're missing our a to the 4th term. So when we write down this in synthetic division, we need to make sure that we're writing a placeholder for our a to the 4th term. So we'll set up our synthetic division. Our 0 comes from here. That's a 1, positive 1. The coefficients will be 5, 0 for the placeholder of a to the 4th, 2, 1, negative 7, and 1. Remember that the last number right here will be the remainder. Okay, and even if it's a 0, it's still the remainder, okay? Alright, so let's start the synthetic division process. The first number 5 comes down and becomes the first coefficient of the quotient. So 5 just comes straight down. We take the 1 and we multiply it by the 5. 1 times 5 is 5. So that goes up here after multiplying. Get rid of some of this stuff. Okay. We will then combine these numbers. 0 plus 5 is 5. We now take the 1 and multiply it by 5. That product goes right here. That will be 5. We combine these numbers. That gives me a 7. So we now take the 1, we multiply it by 7. That product comes up here. So 1 times 7 is 7. We combine these terms. 1 plus 7 is 8. It's now 1 times 8 goes right here. That's going to be 1 times 8 is 8. Combine these terms. It gives me 1. And the last one, we get rid of this. The last one is 1 times 1 is 1. Sorry. Combine those last two terms. It gives us a 2 as a remainder. All right, so now we write what's called the depressed polynomial. So we take the 5, which is 5. A is the variable. The degree drops by 1, becomes a 4, and then we decrease from there. So it becomes 5a cubed plus 7a squared plus 8a plus 1. And we have to add our remainder. 2 divided divided by a minus 1. Okay, let's look at example 3. Notice once again that we have the third term and the first term, but we're missing the second term. So we're going to make sure we place hold the second term. So our 0 is going to be 5. Our coefficients are going to be 2, 0 for the x squared, negative 45, and negative 7. So we're going to do this one a little bit quicker. Bring down the 2. 5 times 2 is 10. 0 plus 10 is 10. 5 times 10 is 50. Negative 45 and 50 is positive 5. 5 times 5 is 25, which gives us 18, and we're out of things to do. Therefore, we write the depressed polynomial. We drop the degree by 1. 2x squared plus 10x plus 5. And add the remainder, 18, over x minus 5. Okay, so here on example 4, we have a slight editorial change that we need to make. Your example has a negative 9 right here. And it's also over here, negative 9x. But in order for this problem to do what we want it to do, we need to change this to negative 27x. So please make that change before we start this problem. Alright, so let's get started. Let's set up our synthetic division. We'll get a 0 of 3. Our coefficients are 3, negative 4, negative 27, and 36. We'll bring down our 3. 3 times 3 is 9. Negative 4 plus 9 is 5. 3 times 5 is 15, giving us negative 12. And 3 times negative 12 is negative 36, which gives me a remainder of 0. So let's write the polynomial in depressed form. So we will reduce the exponent by 1. 3x squared plus 5x minus 12. No remainder. Now let's look at this box that's over here on the right-hand side. This says, recall that if the remainder is 0, then this means that the divisor, this x minus 3, is a factor of the polynomial. So this is a factor. And you remember, factors are something that divide into it evenly. So then it asks us to continue working this problem. It says, can you continue to factor this completely? So what that means is that we're going to continue to factor this hard trinomial. Now, some of you guys are going to want to do this as slide and divide. So I'm going to move this over here using slide and divide. That's going to become x squared plus 5x minus 36. Oops, that's supposed to be an x. X. Oh, where'd the 6 go? 36. 9 times 4 is 36. Positive 9, negative 4. Let's give back our 3. The 3 does not divide into the 4. So our factor there is 3x minus 4. And the second factor does simplify, giving us x plus 3. And so that's the remaining factors of this problem. So that is a little extra step at the end of the synthetic division.